Okay, so we are given a function f of x equals to 1 minus cosine of x divided by x squared. Okay, now we want to calculate the value of the limit of this function at 0. Okay, and okay, first let us can I stop right now? Okay, good. Okay, so now we want to calculate the value of f near to the point x equals to 0. So we can start with let's say minus 0 comma 1, minus 0.1, and also 0.1 as well. And here you'll see that minus 0.01 minus 0.001 and so forth. Okay. Okay, so let us probably I will use Excel because it's quite uh, simple here. So I given x, let's say x equals to minus 0.1, then I need to calculate 1 minus cosine of x divided by x squared there. Okay. Of course, I can copy the function there. Okay, can copy here, and then I can copy once again here, and okay, copy this as well. Okay, to obtain okay, so from this calculation we can guess that the limit is 0.5 or half. Okay, of course we have to verify how do we obtain the value of the limit, but okay, let us take a look at the calculation then. Okay, so in this case, okay, we can guess that the value of the limit here is limit x tends to 0 of 1 minus cosine of x divided by x squared is half. Okay, but we need to verify it. Of course, the previous calculation give us the guess for the value of the limit, but we have to calculate this rigorously. And in this case, the idea is that we use the trigonometric identity for double angle. Okay, and recall that here, for example, if I use the symbol t, cosine to 2 of t equals to cosine square of t minus sine square of t. Of course, I can replace here cosine square of t by 1 minus sine square of t, so that I will have 1 minus 2 sine square of t. Okay, if I use this identity for t equals to x over 2, then I will have limit x tends to 0 of this function, 1 minus cosine of x divided by x squared equals to limit x tends to 0 of 1 minus 2 sine square, but t here is x over 2, so I put x over 2 there. Okay, put x over 2 divided by x squared. Okay, of course I can simplify this to become limit x tends to 0 of 2 sine square of x over 2 divided by x squared. Okay, and we know that we realize that the limit x tends to 0 of sine x over x is 1, right? Okay, and of course I can write this as 2 times limit x tends to 0 of sine square of x over 2 is sine x over 2 over x multiplied by sine x over 2 divided by x. And we know that the value of each limit is half, right? So 2 times limit x tends to 0 of sine x over 2 divided by x, okay, multiplied by limit x tends to 0 of sine x over 2 divided by x. And in this case, I have 2 times half times half here. Okay, of course, the value is half. Okay. The value of the limit, of course, is obviously half. Okay, so this is the verification. Yeah. Okay. Is it clear now from this? Okay. Now, let us continue. Okay, so this case, okay. Okay. Okay, so in this case, let us continue to the next problem. Okay. Okay, so in the next problem, we need to find what is the limit of the function from the graph of the function. Okay. Okay, here, given the graph of the function f, then we want to find the limit of the function at the given point. Okay. For example, okay, in number 3 here is the graph of the function. What is the limit of the function at 0? The limit is, so you'll see that if x is approaching 0 from the right hand side, then the value of f is approaching 0. So the limit here from this picture, okay, so the limit number 3a, limit x tends to 0 of f of x equals to 0. Yeah. And then part b, what is the limit x tends to 1 of f of x? Yeah. Oops, okay, better. Okay, what is the limit x tends to 1 of f of x? The limit is, if, okay, so here, if I consider when x, if I move x close to 1 there, then the value of f is close to, the value is x is equal to 1, then the value of f is close to 2 or 1. The limit is 2, right? It's close to 2, right? So the limit x tends to 1 of f of x equals to 2. Okay. What is the value of f1 there? F1 equals to, from the picture, F1 equals to, F1 equals to 2 or 3 or undefined. So you see that from the point here, the meaning of this point is F1 equals to 3. So F1 equals to 3. F1 equals to 3. And you'll see that here, the limit of the function at 1 and the value of the function at 1 is different. Then the conclusion will be f is not continuous at x equals to 1. Okay. So here you see that the limit of the function at certain point is irrelevant with the value of the value of the function. However, if the value of the function coincides with the value of the limit, then we say that the function is continuous. Otherwise, the function is not continuous or discontinuous at that point. Okay. Okay. Any question or comment? Okay, so now what is the right-hand limit of f? So the right-hand limit means you have to move the value of f of x when x is approaching 2 from the right. When x is greater than 2, what is the limit here? The limit is, the right hand limit is 0. The right hand limit is 0. So you'll see that if x is approaching 2, okay, probably I will, okay, if here, if x is approaching 2 from the right, then the graph of f is approaching 0 here. It's approaching 0. So the limit is here is 0. On the other hand, if x is approaching 2 from the left, then f of x is approaching 1. Okay, approaching 1. So the limit, the left hand limit is 1. E, the limit at 2 is this does not exist. Does not exist. Okay. Okay. Okay, so so here you'll see that okay, start with at 0, the limit is 0. Okay. And then at 1 the limit is 2. However, f1 is not 2, f1 is 3. And then the right hand limit is 0 at 2. The right hand limit at 2 is 0. The left hand limit at 2 is 1. The limit at 2 does not exist because the left hand limit and the right hand limit are different. Okay. And what is the limit at infinity here? 1, because you will see that if you move here, okay, if you move the graph here indefinitely, then it's approaching x equals to 1. So limit is 1. Okay, I will write the on the whiteboard just for our record. What is the first one? The right hand limit. The right hand limit of f at 2 is 0. The left hand limit. The left hand limit is 1. The left hand limit is 1, and the limit does not exist. Does not exist. Okay. And obviously, part f limit x tends to infinity of f of x equals to 1. It's a horizontal asymptote. Okay, any question or comment up to this point? Okay. Okay, for number 4 here, it's a there are 2 graph of function. The first one is on the left like this, and the second one is like this. So what is the limit at 0 for the first one? The limit at 0 is 0. The limit of limit, so I will annotate, limit x tends to 0 of f of x is 0. What happened with the second one? The limit is here, does not exist. Here the limit x tends to 0 of f of x does not exist. So you see that does not exist because it oscillate indefinitely around 0. Actually, you can see the example of this function. Okay, actually, we can try the example of the function will be, okay, so I can take a look at the graph of the function. You may take, let's say, for the first one, for the first one, you may take, let's say, y equals to x sine 1 over x. So you will see that actually the graph of the first function x sine x sine 1 over x. Okay. And the graph of the second one is sine 1 over x, I guess. So, oops. Oops. Hey, this one. Yeah, this is the okay, probably it's zoom in first and then take y equals to sine 1 over x. Okay, so that's the graph of the second one. Y equals to sine. You'll see that around x equals to 1, the value of the function is oscillating indefinitely. So it does not approach any particular real number. That's why the limit of the function okay. Any question or comments so far? Okay. Okay, so I will stop.